Hello and welcome to the next lesson. Today we're going to spend another day on that same chapter, 4.3. And while we're proving identities, here are a few strategies that we can use. First thing we should do is look for things to replace. Like if we see a cotangent, think cosine over sine. Um, just look for things that we can change and make things easier. We want to rewrite everything in terms of sine of x and cosine x. And I should write maybe sometimes off to the side here. Sometimes it's easier to not do that, but a lot of times that's a good method to do if you can't think of anything else. We also want to think about our Pythagorean identities. So if you have square numbers like sine squared and cosine squared together, think, oh, this might be one of the Pythagorean identity, sine squared plus cosine squared equals 1. Or if there's a cotangent squared, look at the Pythagorean identity that has cotangent squared in it. Now we'll want to add fractions if we have two parts and need one. We'll want to simplify fractions wherever possible. And then sometimes we'll want to multiply by versions of 1. Now multiply by versions of 1, that could be cosine of x over cosine of x. It could be cosine of x plus 1 over cosine of x plus 1. This one gets kind of tricky, and we'll get to it. We'll have some problems where we have to do that. Um, and it gets a little tricky. You have to really think when you're using that. All right, today we're going to start off by reviewing a little bit. If we expand this, this is going to be x squared plus 3x minus 3x minus 9. So plus 3x minus 3x cancels out, so it's just x squared minus 9. Now remember, if you have x plus something, x minus something, that's the difference of two squares. Or this is the difference of two squares, and it can turn into this. So if I expand this, it's the same thing. It'll just be 1 minus sine of x plus sine of x, which will cancel out, and that would be minus sine squared x. If I expand this, x plus 3 squared, that's x plus 3 times x plus 3, so that would be x squared plus 3x plus 3x plus 9, so that's x squared plus 6x plus 9. We could do the same with 1 minus sine squared. So we have 1 minus sine of x, 1 minus sine of x. So I'll have a 1, a minus sine of x, another minus sine of x, and then a plus sine squared of x. So when I combine the two middle terms, this would be 1 minus 2 sine of x plus sine squared x. All right. Hopefully that makes sense. Now, try this one on your own. Work with this left side and see if you can turn it into what's on the right-hand side. Now what we do is this would be 1. This would be a cosine x minus cosine x, which would cancel out. And then that would be minus cosine squared x. 1 minus cosine squared x. Let's look at the Pythagorean identity right up here. We want to turn this, a cosine squared x, into a sine squared x. So if I subtract cosine squared x on both sides, 1 minus cosine squared x is going to equal sine squared x. So that just turns into sine squared x. Oh, and by that, we get to the right-hand side, so we're done. Now, when we're done with a trigonometric proof, some people like to write QED to show that they're done with it. Some people, my college professor really liked making a box with 2 little dashes. I don't know why. If you want to come up with your own fancy thing to say you're done, I always like this little box thing. But you can do whatever you want. Make a little fancy design, keep it consistent, and I'll think it's funny as I correct your tests. All right, let's do this one. We're going to start with this left side, turn it into the right side. So if you are going to do this, well, first pause the video and try it on your own and see if you can do it. All right, hopefully you're done. Now there's many different ways to start this problem. We could distribute, we could do this inside, this whole inside first, multiply it by cotangent. Many different ways to start. I'm going to start by multiplying that cotangent of alpha over the parentheses. So I'll have cotangent alpha, tangent of alpha, sine of alpha, plus cotangent of alpha, cosine alpha. Now this is a good instance where we'd want to turn everything to sine and cosine. So this would be cosine of alpha over sine of alpha over cosine of alpha times sine of alpha over 1 plus cotangent is cosine over sine. All right, let's see where this goes. Well, if we cancel out cosine divided by cosine, that would be 1 over 1. Sine of alpha over sine of alpha would be another 1 over 1. And so that just leaves sine of alpha over here. So we'd have sine of alpha on the left-hand side. We're going to add that to cosine squared alpha over sine of alpha. All right, so now to add these, we need a common denominator, which will be sine of alpha. And so if I multiply this denominator by sine, I got to multiply the numerator by sine. So times sine is sine squared. Here we didn't do anything, so we continue with cosine squared. And so sine squared plus cosine squared is our new numerator. And our denominator is just sine of alpha. Now sine squared plus cosine squared, using that property up there, is equal to 1. So 1 over sine of alpha. And 1 over sine of alpha is the same thing as cosecant of alpha. All right. Hopefully that makes sense, and that's how we got through it. I'm going to put a little box down there to tell everyone that I'm done with that proof. All right, here's a new one. Try this one and see how far you get. 1 minus sine squared beta. If I look up here, if I subtract sine squared on both sides, 1 minus sine squared is equal to cosine squared. So I have cosine squared beta over cotangent of beta, which is sine of beta over cosine of beta. So this is the same thing as writing cosine squared beta divided by sine squared beta over cosine squared beta, which is the same thing as writing cosine squared beta times, oh, I see where I made a mistake. Hopefully you have been screaming at the television or your monitor the whole time. Cotangent is cosine over sine. Good thing I caught that before we got too far. So cosine squared beta times the reciprocal, which is going to be sine squared beta over cosine squared beta. Put that over 1. Now cosine squared divided by cosine squared is going to cancel out. And we're left with sine squared over 1, which is just sine squared beta. And we can say we are done. All right. Now pause this one, see how you can do. Now there are many different methods of doing this. I think I would like to simplify both sides first and then combine it. So secant is 1 over cosine of x. Cosecant is 1 over sine of x. So when we divide these, that's like saying 1 over cosine of x divided by cosine of x over 1 plus 1 over sine of x divided by sine of x over 1. Now that division is like multiplying by the reciprocal. And this becomes 1 over cosine squared x plus 1 over sine squared x. Now at this point, every year I have people say this is secant squared plus cosecant squared x. So Mr. Hebrew made a mistake with this problem. Yeah, I understand that that's reasonable to assume that, but I actually didn't make a mistake. So now let's see where we can get from here. Let's make a common denominator and figure this out. The common denominator here would be cosine squared x sine squared x. So I would have to multiply this side by sine squared x, this side by cosine squared x, and when we combine them, we have sine squared x plus cosine squared x all over cosine squared x sine squared x. Now hopefully everyone's shouting that sine squared x plus cosine squared x is equal to 1. You would be correct, so that would be 1 over cosine squared x sine squared x, and 1 over cosine squared x. We can separate this into two separate equations, or 1 over cosine squared x is secant squared x, 1 over sine squared x is cosecant squared x. And that is our final solution. Oh, I should put a box at the end just to show you I'm done. All right, try this one out. Sine theta minus cosecant of theta squared is going to equal negative cosine squared plus cotangent squared theta. All right, so this is equal to sine of theta minus cosecant of theta times sine of theta minus cosecant of theta. Sine times sine is sine squared theta. This would be a minus cosecant theta sine theta. And this would be another minus cosecant theta sine of theta. And this would be a plus cosecant squared theta. All right. So if I have cosecant times sine, let's look at that. That would be just a minus. This is going to be 1 over sine of theta times sine of theta over 1 minus 1 over sine of theta times sine of theta over 1 plus cosecant squared theta. Now this sine of theta divided by sine of theta is 1 on both of those. So 1 times 1 over 1 is going to be 1. 1 times 1 over 1 is going to equal another negative 1. So we have negative 1 and negative 1. And sine squared theta minus 1 plus cosecant squared theta. All right, we want to convert this into something that looks like this. How does sine squared get to negative cosine squared? Well, I could subtract cosine squared from both sides here, and it would be sine of theta is 1 minus cosine squared theta. So this thing is 1 minus cosine squared theta. Cosecant squared theta is cotangent squared x plus 1. So we have cotangent squared theta plus 1. And now I have 1 minus 1 minus 1 plus 1. So that is, all those ones cancel out. So I have negative cosine squared theta plus cotangent squared theta. And that's what's on the right-hand side. So I'm done with my trigonometric proof. All right, hopefully that gets you through the homework. Good luck.